Hello dear students, how are you? I hope you will be fine. So today we will be going to discuss a very important chapter of chemistry, that is some basic concept of chemistry. Okay, this chapter is actually very important for the examination point of view, and in this chapter we're going to study the advanced versions of 9th portion. Okay, that we have studied in the 9th, the mole concept. Okay, and the basics of the elements, compounds, the some laws of chemical combinations. So whatever you have studied in the 9th standard, the advanced portion, the advanced level of this chapter, of that chapter, we're going to study in this one. Okay, so let's start studying. What we're going to, first of all, if I'm just going to discuss in chemistry, what we're going to study generally, that is, there are two types of measures we study, that is qualitative measures, qualitative and quantitative. Okay, qualitative measures and quantitative measures. What is qualitative measures? Qualitative measures when a reaction is going to take place. For example, if I'm saying A plus B react to form C. Okay, so when they react together, what the product is going to form, that comes in the qualitative. Okay, qualitative measures, that when these two substances are going to react, what the product is going to form, that comes in the qualitative measures. And another one is the quantitative. This means that when A react with B, that how much amount of C is going to form and how much amount of A is being required to form a particular amount of C. Okay, so this is the qualitative measure. So for better understanding these concepts, let us start studying the basics of chemistry. That's just we're going to start. Okay, first of all, you know that the matter that you are being studying from your childhood, that what is matter actually. Anything that occupies space has mass is called matter. And generally we have divided the matters into two parts. One is the living and non-living things. Okay, so livings we are going to study in the biology. Okay, now the non-livings we're just going to study here. Non-living things, about the non-living things, that you know that non-living things are made up of matters. Okay, living things are also made up of matters, but we have divided this non-living things into three parts. One is the elements, compounds and mixtures. Means we simply say that the substance or the matter, the non-living matters, we have divided into three parts. One is the element, the second one is compound, and the third one is mixtures. Okay, now coming to the points, you are very much familiar that what are elements. Elements are the pure substance, okay, that consist of only one kinds of atoms. When a substance is going to have only same kinds of atoms, okay, we consider it as element. For example, if you are having a strip of iron, so it is generally going to have similar kinds of atoms of iron. Okay, for example, if you are having a gas, hydrogen gas, in a sample, okay, in a tumbler or somewhere, so this hydrogen gas is going to have the similar kinds of atom, that is going to have one electrons in its outermost shell with one nucleus. Okay, so they're going to have this type of atoms. Okay, so we simply say that an element are the pure substance that consists of only one kinds of atoms. Okay, similarly, if I'm saying that what are compounds, you know very well that compounds are the substance in which two or more atoms chemically combine together. Two or more atoms chemically combine together. Okay, chemically combined together. Okay, and you are very much familiar that in mixtures, two or more substances are mixed, but they are not chemically bonded, they are physically bonded. Okay, so here two or more substance is mixed and they are physically bonded. Okay, so let me explain you each and everything in detail little bit. Okay, because we are just studying from the basics, so let's start studying. You know that in elements atoms are the basic constituents, or we can say that the same kinds of atoms are going to have in a particular element. Okay, for example, if I'm saying the atoms elements, if I'm having an element of hydrogen, then it is going to have the atom like this with 1 electron. Okay, if I'm just going to have a carbon atom, okay, then it is going to have 2 electrons in the first shell and the 4 electrons in the outermost shells. Okay, like similarly, if I'm going to have this oxygen atom, have this oxygen atoms, okay, and this is the nitrogen atom. It is going to have it is going to have 2,5 electrons, and it is going to have 2,6 electrons. This is the oxygen atoms, oxygen atom. This one is the hydrogen atoms, hydrogen atoms. This one is carbon, and this one is nitrogen atom. Okay, you are very much familiar with this one, that the nitrogen atoms and the oxygen atoms, there is only difference between the nitrogen and oxygen atom is that oxygen atom has 1 extra electron as the nitrogen is going to have. Okay, it have 5 electrons in its outermost shell, there are 6 electrons in the outermost shell, but you know that the property is totally changed. You cannot inhale the oxygen atoms. Okay, sorry, you cannot inhale the nitrogen atoms. You cannot inhale, or you cannot, if I'm saying that you cannot survive with the nitrogen gas, you require the oxygen gas. Just because of 1 electrons, the property of the elements has been changed. So if I'm saying that elements, different elements have different kinds of atoms, you see that hydrogen elements is going to have different kinds of atoms other than with other elements like carbon, nitrogen, oxygens. Okay, and you know that this is the number of electrons that is making the different element different. Okay, like you have this 4 electrons, this you have the 1 electron, this you have the 5 electrons, you have the 6 electrons. So the nitrogen elements is different from the oxygen elements, carbon element is going to have is different from the hydrogen. Okay, so now you understood this my point, that what I want to say, that the electron is responsible, number of electrons in outermost shell is responsible for different chemical properties of elements. Okay, so if I'm saying that carbon is behaving different from with iron, so why it is behaving different? Because they have the different numbers of electrons in the outermost shells. Okay, so why the outermost shell, that we will discuss it later. Okay, now moving to the next part is that coming to the point that we're going to discuss, this is elements. Now you know that is compound. What is compound and what is the difference between the mixtures? Let me explain you first this one. Okay, so if I'm saying this is an element and this is a compound, okay, you know that hydrogen gas when mixed with oxygen gas or chemically combined together, so it form water. Okay, water, you know this hydrogen gas is actually combustible gas, and it's help in combustion, but here you see that water extinguish fire. Okay, so why, you know that why these elements are not showing the property of each other, or if I'm saying that the hydrogen is present in the water, oxygen is present in the water, then why it is not showing the property of both hydrogen and oxygen? So you need to understand this one very importantly. Rather, if we mixed, that if I'm having another examples of mixtures, okay, like if you are having water inside it, and you add some salt to it, okay, that if you are having, this is water, and then you add some salt to it, okay, and you will feel the taste of the water will become salty. Then you add some sugar to it, then you will feel the taste of this will be both sugary as well as sweet as well as salty. And when you add some lemon to it, then it will be both sour saccharine taste, sugar, and means all the three tastes will be coming here. So what actually happens in the mixtures is that the substance that we are mixing, I'm assuming this one is the particles of water, and that's going to have some intermolecular space. Okay, so what is going to happen is that the sugar particles are going to enter in the intermolecular space of these. They are not physically bound, they are not chemically bonded, they are physically bonded, and they are just going to have the force of attraction, but they are not making any chemical bonds. Okay, and similarly the sugar particles, these are the salt particle will go to the into the space of this one. Okay, so that's why they are showing the similar property. Okay, this one is water particle, this one is sugar particle, let it be, and this is the salt particle. Okay, so they are showing their property because they are just coming into the intermolecular space. They are not, electron transfer is not being taking place here. Okay, now what happens in the water? You know that when a compound is formed, okay, so you know that hydrogen and oxygens were not showing the property of both hydrogen and oxygen in water. Why it is not showing the property? Can anyone in the class can give me the idea? So let me explain you this one, that if I'm having this hydrogen gas, okay, and this one is oxygen gas, this is forming the water. Now let's take example of the atom. Okay, this one is the oxygen atom that is going to have 2 electrons in the first shell and the 6 electrons in the outermost shell. Okay, 1 2 3 4 5, and this one is 6. And the hydrogen atom that is going to have only 1, and that is also going to have only 1. Okay, now you have heard the concept of stability. Okay, that every element wants to be stable. Every elements want to be stable. Okay, stable, and it wants to attain the stable electronic configuration to the nearest noble gas. Okay, so if I'm saying that is what is noble gases, let me explain you first what are noble gases. Noble gases or gases are those gases or those elements that are going to have the complete electronic configuration, means they have their completely filled shells. Okay, for example, you know that the first shell can accommodate the maximum number of electrons is 2. So that gas or the substance or the elements that is going to have 2 electrons in its outermost shell or completely filled shell, the first shell, that is helium. The other one is the second element, that is in the second shell can maximally hold the number of electrons, that is 8. So you see that 3 and 3 is 6 7 8. Okay, so this gas is the neon gas. Okay, and similarly the next one is argon. So every elements want to attain the stable electronic configuration to the nearest noble gas. Okay, for example, this is hydrogen, and this hydrogen is going to have only only 1 electron in its outermost shell. So it wants to have the stable electronic configuration to that of helium. Okay, similarly that oxygen, okay, that oxygen atom is going to have 6 electrons in its outermost shell, 1 2 3 4 5 6. Okay, and now this oxygen atoms wants to be stable to have the electronic configuration to the nearest noble gas, that is of neon. Okay, so what is going to happen here is that these elements are going to share their electrons. Okay, means oxygen wants to have 8 electrons, and this wants to have 2 electrons. Why? Because its nearest noble gas is that helium, and this the nearest noble gas for this oxygen is neon. So it wants to have 8 and it wants to have 2. Everybody clear? So let me explain you that what happens when a compound is formed. So here you see that this oxygen atom is going to share its 1 electron with this one. Okay, and 1 electron with this hydrogen atom. Okay, similarly this hydrogen atom is also going to share its 1 electron with this oxygen atom and this oxygen atom. Okay, so you know very well that for some time when these electrons are being shared, okay, so this hydrogen is going to have 2 electrons when these electrons come into this one and this one, and similarly this is also going to have 2 electrons, okay, 1 2, this shared when this is being shared, okay, and similarly this oxygen atom is also going to have 8 electrons when this one is shared. So this electron when shared with this one, okay, now you understood. So this is 2 electrons, this when it is shared it becomes 8. So now you know that since in a compound the electron exchange is going to take place, electron exchange is being taking place, okay, that are not coming, means if I'm saying that like in the mixtures, generally the substance come into intermolecular space between them, okay, they are mixed together, but here you see that they are not mixing, they are exchanging their electrons, and you know that this electron is being shared here, okay. So when the electrons are being shared, so number of electrons of the atoms increases or decreases. That's why when the oxygen is going to have 8 electrons in its outermost shell, then it will not become the oxygen, it will behave like the property, showing the property of neon. And when this hydrogen atoms get 2 electrons, then it will start showing the property of helium atom. It will not show the property of that of hydrogen atoms, okay. So like we are having the same, I was just explaining you here, okay, that this is the that was the oxygen atoms. Let me explain you. Okay, there is just one electron difference here, okay, there is just one electron difference here, and you see here that this oxygen atom, when you see this, simply if I'm just saying that if I remove the 1 electron from this oxygen atom, it will start showing the property of nitrogen atoms, okay, and if I add 1 electron to this nitrogen atom, it start behaving like the oxygen atom. So in water, since the electrons are being exchanged, so number of electrons are not fixed in the hydrogen atoms, in the oxygen atoms. So in water, that's why they are not showing the property of hydrogen and oxygen. Water has its own property and a new substance is formed. So let's talk about this one. Now you understood that why in compounds the elements does not show their property, because in compounds elements are chemically bonded together, and you know that when the substance is chemically bonded, then the electrons are being exchanged, and electrons are responsible for showing the property. If the number of electrons are being changed, if the number of electrons are not same, then what is going to happen? The element will not show its property, it is not showing its own behavior, okay. But why in mixture the compound show the substance or the mixtures, why they show their property? Just because they are just coming into the intermolecular space and they are not mixing together, they are just mixing together, they are not chemically bonded, the electrons exchange is not going to take place, they have their electrons they were having previously, okay. So that's why they show their property. So let's move further. Now let's move further to the mole concept, that is very important, okay. Just moving before this one, let's start, because we are just studying this one. So now you know that the other mixtures, that is mixtures we have divided, that you have studied in the 9th standard, that is heterogeneous mixtures and the homogeneous mixtures, okay. Now heterogeneous mixtures we have divided, that is suspensions and colloids, and the homogeneous mixtures are the true solutions, okay. Now let's talk about this one, that when a solution is formed, okay, when a solution is formed, so we have some solvent and we have a solute, okay. Then when we mix together, they form a solutions, okay. When solute and solvent mix together, they form a solutions. But the students are going to have some confusion regarding this one, so let me explain you with this one. For example, if I'm saying that we have a solute, okay, that is in solid state, and that is mixed in the solvent, that is in liquid state. If the solution is in liquid state, so you can simply say that the solvent is going to have the same state as that of solution, okay. For example, let me explain you are very much familiar that when you mixed that you have water, okay, and let's you suppose mixed, this is water, and let's suppose you mix salt to it, so you know that that is a solute, okay, and this is the solvent, okay. Because I'm just saying that because in the numerical problems you're going to face the problems, you will not be able to understand that which is solvent and which is solute, because we are going to study the molality okay, in this chapter, or this is the stoichiometry, and this is important. So we're going to discuss this ones, okay. Some students does not differentiate between the which is solvent and which is solute, okay. So if I'm saying that this one is solute, this one is solute, and this one is solvent, so you say that water is liquid because, and we are just having a pinch of salt to add into this, so the water is in more quantity, so it will be considered as solvent. No, this is not. The substance that is in bigger amount or the larger amount is not considered to be as solvent, okay. Solvent is just that substance that is going to have the similar physical state of that solution. Let me explain you. This is, for example, if I'm having this salt solution, salt when added with water, you simply know about this one, that it forms salt solution, okay, salt solution. But when why I'm saying this is salt solution and this one's solute, and which one is solvent, let me explain you. So this one is the liquid state, you know that water is in liquid state, okay. This one is solid, so thus the solution is going to have both the same state here, and it is solvent, okay. This one is solvent, meaning the same state of water and the solution. This one is solvent, this will be solute. Similarly, if I'm saying that if you are adding mercury, okay, and another one is sodium, Na, sodium, and you know that mercury is in liquid state and sodium is in solid state, and when they mix together they will form sodium amalgam, okay. So you must be very much familiar with this one, that sodium, the state of sodium amalgam is solid, okay. If you are mixing sodium with this mercury, so thinking that mercury is in liquid state, don't think that it is a solvent. No, it is not a solvent. Actually, solvent is the same as that state of sodium, as that state of solution, okay. So if the sodium amalgam is going to have this solution is going to have the solid state, then this sodium is also going to have solid state. Though both are going to have solid state, so we will simply say that this is solvent and this one is solute, okay. Now moving further, so now you have understood that what are elements, what are compounds, what are mixtures, why in compounds elements does not show their properties, and moreover you have studied that if two substances are mixed together, okay, then the state of the solvent is same that of solution, okay. So now let's move to the next topic, that is mole concept, okay. Mole concept, and that is important, very important for the examination point of view, and this chapter, this topic will going to bother you in the whole 11th and 12th standard, okay. So this portion is very important, okay. This portion is very important, so let's start studying this portion, okay. You know that when atom was discovered, the people or the scientists were very habitual in knowing the structure of atoms, that how the atoms is and what is the shape of atoms, okay. So after getting that electrons, protons were discovered, so they would start giving the structure, different structures of atoms, okay. So let's move. When they start giving the structure, so you know that the Thomson gave plum-pudding model, watermelon model, okay. Then Rutherford gave its model, then after the Bohr model was given, okay. So atom finally was given. Now the mass of the atoms, the scientists were very eager to know the mass of the atoms. Okay, so they started finding different techniques that how can we calculate the mass of an atoms. Okay, so let's discuss this, that what is mole. So mole is just a number. What is mole? Mole is just a number that is going to have a value of 6.022 into 10 raised to the power 23. Okay, where it come from, I will going to explain you. Okay, the mole is just a number. Like we have 1 dozen. 1 dozen is going to have a value that is of 12. Okay, 1 decade means a period of 10 years. Okay, so 1 century, we are going to have a period of 100 years. Okay, so similarly we're just going to have in chemistry, we are just going to have this number that is 6.022 into 10 to the power 23, that is going to have value that is called 1 mole. Okay, and where it come from, I'm going to explain you later. Okay, so just before coming to this one, let me explain you that how does the mass of the atoms were calculated, and how these substance are being calculated. Okay, so let me discuss this one. Wait a minute. Okay, let's coming to this one. First of all, if I'm saying that what is atomic mass of a substance, you know that atomic mass of an element is the mass of an atom, or it gives an idea that how much an element is heavier to 1/12 the mass of carbon 12 atom. So let me explain you one more time at what I'm saying here. Okay, actually if I'm saying the mass of an oxygen atom is 16 AMU, so it means that this oxygen atom is 1/12, sorry, is 16 times heavier than the mass of carbon 12 atom, and it is not the full, it is the mass of 1/12 the mass of carbon 12 atom. Okay, so from where does it comes from, let me explain you. Okay, actually you are very much familiar that when we are going to measure something, okay, like if I'm going to measure some distance, so you know that if I'm just going to measure the distance between A and B, so you are just measuring this one, you are just comparing this one, okay, with the particular length that is called meter, and you are just multiplying this one. If it is 5 times, then it is 5 meter. If it is 10 times, then it is 10 meter. Okay, similarly if you are having some weight, so you just start comparing with a particular mass or particular weight, that is 1 kg. If it is 2 times, then it is 2 kg. If it is 3 times, that is 3 kg. If it is 0.5 times, then it is 0.5 kg. Okay, so this is that we have just arbitrarily chosen some length, and we just say that it is 1 meter, and we just start comparing this distance with this one. Okay, similarly we have just taken some mass that is of, we considered it is 1 kg. Okay, and just we start comparing that with the substance, that how much it is heavier. Okay, similarly when we are just we want to calculate the mass of carbon atoms. Okay, sorry, if we am just going to measure the mass of if I'm just going to measure the mass of some atoms, okay, we need the atoms, we need something that we need to compare it. Okay, let me explain you one more time that what I want to say here. That suppose if I'm going to measure a mass of a truck, okay, the weight of a truck, then I'm going to measure this, the truck will go on this one, okay, on this bigger scale. Okay, and we just start comparing it with the huge masses that is going to have 50 kg, 1000 kg. Okay, so we'll just start comparing with us. But if you went to the gold to buy some gold, okay, to the jeweler shop, then will that mass be used in measuring that substance, in measuring that ornaments? No, because this is a very huge mass. Okay, and you cannot measure the gold that you are buying, that is only 10 gram, 20 grams, or with that mass, that huge masses. Okay, you cannot measure the same thing because they are very small in size and they cannot be measured with this one. Okay, similarly, if you are just going to measure the mass of an atom, so you cannot measure this one in the kilograms or the milligrams, because milligrams is very much larger mass as comparison to the size of an atom. So what we need to do here is we need to make some substance or some atom to which we are just comparing it. Okay, so let's suppose the scientists made the hydrogen. First, hydrogen is the smallest element, smallest atoms, and they just start comparing it with the hydrogen. Initially hydrogen was taken. That we'll consider that hydrogen, we just measure the, let's suppose if I'm having this carbon atom here, okay, and this one is hydrogen atoms here, then we start putting this one carbon atom here, and we know that when we put 12 hydrogen atoms here, 12 hydrogen atoms, okay, so then they become equivalent. So first of all, initially we just make the hydrogen atom as a standard atom that we are just comparing. We just start comparing it with the other elements, other atoms of the different elements. Okay, for example, if I'm saying that magnesium, if I'm just going to measure the mass of magnesium, so I just simply say that it is 24 times the mass of hydrogen atoms. Okay, 24 times the mass of that hydrogen atom. So means 24 hydrogen atom is equal to 1 atom of magnesium. Okay, so we just take we simply make the atom as a standard unit for measuring the mass. But there are some problems with the hydrogen gas, so it is being replaced. Okay, then we convert, or we change the unit with the oxygen, and then we start measuring the mass, start comparing the mass with the oxygen. Okay, now this, we have just taken the oxygen atom as a standard unit, and we just start comparing the mass of different elements with this one. Okay, now later the oxygen was also removed. Okay, oxygen was also removed and changed, we can simply say. Then finally we have taken the carbon, because carbon is present in adequate amount and it is generally not found in the combined form. Okay, that is in the form in the graphite, that is in purest form. So we just start comparing it, means we have just taken the carbon atom. Everybody going my point? We have just taken the carbon atom as standard atom for comparing the mass of other atom. Okay, now what we is going to have, there is a problem that you know that carbon atom is not the lightest element. Okay, so what we are going to have this when we put this one carbon atom here, and then we're going to have the 12 hydrogen atoms here. Okay, 12 hydrogen atoms means this is 12 in numbers. Okay, so if we are going to have the, if I ask you that what is the mass of one hydrogen atom, that it will be coming in decimals. Okay, if I'm saying that the mass of one hydrogen atom will be 1/12 times the carbon atom, the mass of carbon atoms. You know what I'm saying, that if you are having, if you just let's suppose if you are having a 5, just consider that you are having a 5 kg mass as a standard mass. Okay, now what you will give the value to the 1 kg mass substance? It will be 1/5 of the mass of the 5 kg substance. So in order to, because when we are having this carbon atom that is bigger in size, and if we are just going to compare it with the mass of hydrogen atom, then it will be coming in decimals. Why? Because 12 times the hydrogen atom, 12 hydrogen atoms are going to have equivalent mass of carbon atom. Okay, one carbon atom. So what we did actually, we just broke this carbon atom, into 12 parts. Okay, 12 parts, and this, like we have pizza. Okay, now you know that now this, you know that this is a mass of one hydrogen atom, this is one hydrogen. Okay, this 12 hydrogen atoms. Okay, and this one, let's suppose this. Now this, you see that they are the 12 hydrogen atoms. Okay, and this one piece is going to have the equivalent mass of that one hydrogen atoms. Okay, this is going to have equivalent mass of that one hydrogen atoms. Now what we're going to discuss here is that now this piece is considered to be as standard mass. Now we did not consider as a whole atom of carbon as an standard mass. We just considered its 1/12 part. Means take an hydrogen atom, sorry, take a carbon atoms and break it into 12 parts. We cannot break the atoms like this one, but just considering. Okay, so 1/12 part of that carbon atom is considered to be a standard part, standard, okay, standard mass for comparing the mass of other elements. Okay, for example, if I'm just going to compare, let's suppose if I'm having this this carbon atom, okay, this carbon atom which is going to have, when we have, let's suppose this is the carbon atom and this one is the magnesium atom. Okay, so we know that the magnesium, that we experimentally we observe that one magnesium atom is going to have the equivalent mass of 2 carbon atoms. Okay, and we put 2 carbon atoms one side and this magnesium atoms on the other side, we simply get equivalent mass. Okay, they are just equal in size, equal in weight. But here we are not saying that one magnesium is going to have the 2 times of or the 2 mass. No, it is not going to have 2 mass. Okay, why? Because we have not chosen the as a carbon atom, as a whole carbon atom for the standard mass. We have just chosen its 1/12 part, 1/12 part. Okay, so if I'm going to have one carbon atom here, so complete one carbon atom, so it mass, it is going to have 12 such part. It is going to have 12 such parts. So one carbon atom is going to have 12 times the 1/12 part of carbon atom. Okay, now there are 2 such parts. There are the two carbon atoms, so that is going to have total 24 such part. Okay, and thus we considered it that the mass of we just considered that there is a 1/12 mass of carbon atom. Now you understood everything, that 1/12 mass of carbon atom is considered to be the standard mass for comparing the mass of other atoms. Like we have just considered this at very small weight and we start comparing it. Okay, so now let's discuss that 1/12 the mass of carbon atom was considered as standard mass for comparing bring the mass of other elements. Okay, and now you know very well that the carbon atom is going to have 2 isotopes. That is, one carbon is going to have 14 mass, another one is going to have 12 mass. So we just select which one atom here, that is going to have carbon 12. So the mass of 1/12, the mass of carbon 12 atom, we are just going to have specific, that we are not just considering the carbon atom that is going to have 40 mass, because there are the 2 types of atoms of carbon that is going to have masses, and that is going to have, one is going to have 14 mass, another is going to have 12 mass. So we are just considering that the one which is going to have 12. Okay, so the 1/12 the mass of carbon 12 atom was considered to be a standard atomic mass unit for considering this one. That is considered to be as 1 AMU. We cannot write every time that 1/12 mass of carbon atoms. Let I am going to explain you. For example, if you are searching for the mass of magnesium atom, so magnesium atom is 24 times the mass of 1/12 the mass of carbon 12 atom. Similarly, if we go to the sodium atoms, it is 23 times the 1/12 the mass of carbon 12 atom. And if I'm going to with oxygen, then it is going to have 16 times the mass of 1/12 the mass of carbon 12 atom. So this, every time we are not just going to write this one, that 1/12 mass of carbon atom. So we just give it a standard unit, that is called AMU, that is called atomic mass unit. Okay, so we just simply write it like this way, that if I'm going to have the magnesium is going to have 24 mass, and it is going to have 12. Okay, if I'm going to have magnesium is equals to 24 times the mass 1/12 mass of carbon 12 atom, so it is just going to have 24 AMU, because we just consider this one. Now coming to the next point is that from where we get this 6.02 into 10 power 23. Okay, from where we get later actually because this is very important, that we're going to study the mole concept, and mole is very important, mole concept, and this is very important. Okay, so as the discovery, as we become the means technologies are being increased, okay, so we start measuring the mass of by the special techniques, by a special spectroscopy method, we are just able to calculate the mass of one carbon atoms in grams, because gram is our standard unit. Okay, later we were just comparing it with the atomic mass of 1/12 mass of the carbon 12 atom, but as the techniques are being increased, or we become highly advanced, we are just able to calculate the mass of one carbon atom. Okay, and that was actually that the mass of one carbon atom was found to be that is 1.99 into 10 raised to the power minus 23 in grams. Means we are just able to calculate the mass of one atoms in grams, because we usually measure the mass in grams. So that is very, very important, and this has changed. This calculation of mass of atoms in grams has changed various things in calculations. Okay, this is a great discovery, okay, and the great achievement for us, that we are just able to calculate the mass of an atoms in grams. Okay, so we just find the mass of one carbon 12 atom, that is going to have the mass that is 1.99 times power, approximately 2 into 10 power minus 23. Okay, now this is not our standard unit. You know that we have not considered the whole atom as one carbon atom, we are just considering its 1/12 parts. So considering this one with 1/12 parts, so if I say that one atomic mass unit, that is going to have the mass of 1/12 mass of carbon atom, that is equals to the mass of carbon 12 atom was found to be 1.99 into 10 power minus 23, and when we divide it by 12, because it is 12th part, 1/12 means 12 part of this one is considered to be as AMU, 1 AMU. So when you cut it, you will get 1.67 into 10 power minus 24 grams. So this is the value of 1 AMU in grams. Okay, this is the value of 1 AMU in grams. Okay, now just give me 5 more minutes. Okay, that I'm going to explain you that from where this 6.022 into 10 power 23 comes. Okay, so let me explain you. Now when the scientists have calculated, because we are just going to, we know the mass of different element, like we have the mass of sodium atom, that is 23 AMU, 23 times the mass of 1/12 carbon atom. Similarly, we have the magnesium atom, that is going to have 24 AMU. Like we have the nitrogen atom, that is going to have 14 AMU. Oxygen atom, that is going to have 16 AMU. Sulfur atom, that is going to have 30 AMU. So the scientists were eager in knowing that how many number of atoms will be there if we have the similar mass but in grams. For example, how many number of atom will constitute, means how many number of atoms will be there when we have, instead of 23 AMU, if we have 23 gram mass, if we have 24 grams mass of magnesium, because we can calculate the mass, we can measure the mass of 24 grams easily. Okay, so how many number of atoms are there if we have the same atomic mass that an atom is going to have, but in grams. Okay, that if I'm going to have, how many number of atoms will be there in nitrogen if we have 14 gram of nitrogen, how many oxygen atoms will be there if we have 16 gram oxygen, how many sulfur atoms are there if we have 32 gram sulfur. Okay, so scientists were very eager that they started calculating that how many number of atoms will be there. Okay, so let's consider the calculation of number of atoms. Okay, you know that very well that one that one sodium atom is going to have mass that is 23 AMU. Okay, and now you can simply say that you have calculated the mass of AMU, means the value of AMU in gram, that is going to have 1.67 into 10 to the power minus 24. Okay, so one sodium atom is going to have this mass in grams. If I just going to calculate this one, then how many, or if I can write it like this way, that 23 into 1.67 into 10 to the power minus 24 gram weight, or the this mass is of one sodium atom, then what will be the, how many number of atoms will be there when this mass has become 23 grams? So let's assume that by what number you are going to multiply this in order to become divide, or how can you make this exactly 23 grams? So this number, because you want to calculate that how many number of atoms are there in 23 grams of sodium. So in order to calculate this one, what you need to do is you are just going to cut this number, and for that you are just going to divide this number by 1.67 into 10 to the power minus 24, so that will get cancelled out and will give you 23 grams. And now similarly you are just going to this one, you are just going to divide 1.67 10 to the power minus 24. Okay, because if you are dividing a number on the left hand side, then you are dividing the dead numbers on this the right hand side also. Okay, so this is sodium atom, there are number of sodium atoms, so when you cut it, you will get, it will cancel out and you will get 23 gram of sodium atom is going to have, when you divide this value, you will get the value that is 6.022 into 10 to the power 23 atoms. Okay, every time you are going to find out this value. Okay, so this number comes, that is 6.022 into 10 to the power 23. Let me explain you one more time, that if you have a mass of an element, atomic mass of an element, let's, for example, if I'm going to say that the mass of sodium atom, or let's take the mass of sulfur atom. If I'm saying that sulfur atom is going to have mass, one sulfur atom is going to have mass that is 32 AMU, or you can say that 32, the value of 1 AMU is 1.67 10 to the power minus 24 grams. Okay, so if this is the mass of one sulfur atom, then this is very small value. Okay, so if you have taken this mass 32 AMU, so that is going to have the mass of one sulfur atom. So if you take the mass instead of 30 AMU, if you take the mass of 32 grams, then it will be equivalent to the mass of 6.022 into 10 to the power 23 atoms of sulfur. You understood? Means when you take the mass, same mass, instead of in AMU, if you take this mass in grams for a particular element, same atomic mass, that if you are going to have 14 AMU, the mass of one nitrogen atom, so if you take this 14 gram gas, then it is going to have the number of atom, that is 6.022 into 10 to the power 23 atoms. Okay, so this number was always coming, so we give this number again, this number that is called 1 mole. So if I'm saying that 1 mole of oxygen atom consists of 16 gram mass. If I'm saying 1 mole of sodium atom is going to have 23 gram mass. Okay, if I'm saying that 1 mole, you know, 6.022 into 10 to the power 23. Okay, so if I'm saying that this 1 mole of calcium atom is going to have 40 gram mass. Okay, so this numbers come from here. So if you are having any doubt regarding to this topic, Okay, you are very much familiar that we didn't understand each and everything in one class, in a single class. Okay, so it will take time. So if you are having any doubt regarding to this one, we will discuss it in the next class. Okay, don't bother that if you are not getting anything in this class. If you are having any doubt, you can ask me right now. But if you are still having some doubt regarding to this problem and you are not saying anything, we'll give you the homework. Do that type of questions. You will be very much familiar with the questions and you are able to solve that one. And if you are still having some problem, then we'll discuss in the next class. Okay, we don't become genius in a single class. Okay, so it take time. Okay, so that's all for today. We'll meet you in the next class, dear students. Okay.